Let's continue looking at factoring a trinomial with a lead coefficient of 1, as well as looking at something called some special cases. It's going to be the difference of two squares. Okay, so just a reminder of what we talked about yesterday. When I'm saying a lead coefficient of 1, when we're talking a trinomial, remember a trinomial is 3 terms. So something like x squared plus bx plus c. So 3 different terms. Remember, our pattern told us that the very last number, we want to be thinking about numbers that multiply to that last number. The number that's connected to x, which is our b term, we want to find numbers that add to it. So that's the pattern, what multiplies to the last number but adds to the number in the middle. So when the directions ask us to factor completely, factor means that we want to look for a greatest common factor, but then try to get everything into terms of multiplication. So because this first problem says x squared plus 8x plus 16, it's an addition problem. We want to turn it into multiplication. So if we quickly look for a GCF, remember from the day before, the moment that there is a 1 in front of the x squared, the only number that everything can be taken out is a 1. That's the biggest number that they're going to have in common. And if I take out a 1, it doesn't end up changing any of the numbers. If I look at the very last term in this trinomial, it's 16. There's no variables there. So I scanned, the only number I could take out is a 1. There are no variables I can take out. So in this particular problem, there is no GCF. And that's usually going to be the case. If there's a 1 in front of an x squared, you're not going to have a GCF. So then remember, the pattern is I want to look for numbers that multiply to the last number but add to the number in the middle. And so what we can do is we can start by making a chart. I'm thinking about numbers that multiply to 16. So, you can always do 1 times 16. That definitely multiplies to get you 16. But notice that if I add those two numbers, the number that I get is 17, which is not the number in the middle. I'm looking to see the number 8. So that means that 1 times 16 doesn't work. If I do 2 times 8, that multiplies to 16. Now I want to check to see if it adds to 8. Well, 2 plus 8, sorry, my pen is being bad. 2 plus 8 is going to give me 10. Once again, I want the number 8. Adding anything onto 8 wasn't going to get me there. So another set of numbers, while it multiplied to 16, didn't add to the number in the middle. So next thing that can multiply is 4 times 4. That multiplies to get you 16. Notice that when I add 4 and 4, it will give me 8, which is the number that I want in the middle. So that means the two numbers of 4 and 4 are going to be the two numbers that I want form part of my final answer. So now to write my final answer, we are going to, like I said, turn this problem into a multiplication problem. Because it is a 1x squared, we get to start each of our parentheses with a 1x. Now remember, because it is a 1, you don't really have to write that in front of the x. You definitely can if you want. It's just not necessary. Because in my chart, both those 4s are positive, I'm going to put plus 4 and then another plus 4. This is going to be my answer. If you are unsure that this is your answer, remember, you can always then go back and do what we did at the beginning of chapter 8, and you can multiply this out. If I was to do the box method or the distributive method, it would get me back to my original problem of x squared plus 8x plus 16. We take a look at the next problem. X squared plus 3x minus 40. Once again, because there's a 1 in front of the x squared, we're not going to have a number bigger than 1 that they have in common. Because the 40 doesn't have a variable, we scanned it, but there is no GCF. So then the pattern tells us we want to find numbers that multiply to the last number and add to the number in the middle. So be very careful with your signs. This time, 40 is negative. So when you're thinking about two numbers that multiply to a negative, you have to have one positive and one negative. So if I start trying to think of some numbers, notice that one number would be negative 10 times 4. That definitely multiplies to negative 40. If I start trying to add those numbers together, remember, I want to get the number that's in the middle, which is 3. So if I take negative 10 plus 4, that gives me negative 6. So it's not quite the number that I need. So that means those two numbers, while they multiply to negative 40, don't give me positive 3. So if I keep trying to think of other numbers that multiply to negative 40, another combination would be negative 8 and positive 5. That multiplies to negative 40. Notice that if I add those two numbers, negative 8 plus 5 gives me negative 3. We're so much closer. I want a positive 3, and right now it's negative 3. Hopefully, you're kind of aware then what we need to do is just flip those signs around. If I make the 8 positive and the 5 negative, I still have that multiplying to negative 40. But when I add them this time, 8 plus negative 5, that's going to give me the positive 3 that I'm looking for. So the two numbers that I need in my final answer have to have a positive 8 and a negative 5. So remember, we write our final answer as multiplication. Because it's a 1x squared to start off my original problem, we want 1x to start off each of our parentheses. The numbers that we found in our chart that multiplied to negative 40 and add to 3 are going to finish out the rest of the parentheses. So a positive 8 and a negative 5. And here are my two factors. Okay, if I take a look at the next problem, we have x squared minus 7x minus 30. So once again, because there's a 1 in front of the x squared and there's no there's no letter with the negative 30, there is no GCF. So that means we're just looking to find what two numbers multiply to negative 30 but add to negative 7. So when I'm thinking about my chart, because it's a negative 30, I know that one number is positive and one number is negative. So if we start thinking about numbers that multiply to 30, well, negative 6 and positive 5, that multiplies to negative 30. If I try to add those two numbers, notice that that gives me negative 1. Still not the number that I want. I want a negative 7. So what are some other numbers that multiply to negative 30? Well, negative 10 and positive 3. When I add those two numbers, that will give me the number that I'm looking for. So negative 10 and positive 3 are going to be a part of my factors. So in my parentheses, because it's an x squared starting us off, we'll want a 1x to begin each of those parentheses. And then the numbers that I have highlighted from the chart need to fill in the rest. So we'll want a negative 10 and a positive 3. If you have those numbers switched around, that's fine, as long as the 3 is still positive and the 10 is still negative. If we take a look at this fourth problem, we have x squared minus 7x plus 12. Checking to look for a GCF with the 1 in front of the x squared and the no variable with the 12, that tells me there is nothing that those three terms have in common. So once again, we're thinking about our pattern, what multiplies to the last number but adds to the number in the middle. Notice that I want to multiply to a positive. So what two numbers multiply to 12? Well, 3 times 4 does. Notice that if I was to add those two numbers, I am going to get 7. That is almost the number that I want. I really, though, want a negative 7. Here's the thing. If I just try to make one of those numbers negative, I'm not going to get it to multiply to a positive 12. So anytime you are multiplying to a positive number but adding to a negative, hopefully remember that two negatives multiply to give you a positive. Negative 3 times negative 4. And then if I add those two negative numbers, it will give me the negative 7 that I am looking for. So don't forget, if it multiplies to a positive but adds to a negative, both numbers are negative. So then when I'm writing my final answer, we'll start each of our parentheses with an X, and we'll fill in the rest of the parentheses with the two numbers from our chart. So X minus 3 times X minus 4. Last two problems here look a little bit different from the previous problems. Notice that this time I do not have a trinomial. Remember, trinomial's 3 terms. Right now what I have are 2 terms. These are binomials. Notice that what is missing is the middle term with an X. However, if you would like, you can always write that in. If it's missing, it's because it's really a 0x. So you can think of x squared minus 9 as x squared plus 0x minus 9. Because there's still technically a 1 in front of the x squared and there is nothing with the variable with the negative 9, once again, just like all our previous problems so far today, we don't have a GCF. But now the concept is still the same. We're looking for numbers that multiply to negative 9, but now technically add to 0. And so if that is the case, you want to find one positive and one negative number, but if it has to add to 0, we want it to actually be the same number, but opposite signs. And so that's why this is called a difference of two squares. If you think about it, what that 9 is we call a perfect square number. We can find two of the same number that multiply to 9. That would be 3 and negative 3. Okay, that multiplies to negative 9. If I add those two numbers, 3 plus negative 3 is going to give me the 0 that I'm looking for. So anytime you have a problem where there is a missing term of x, think of it as a 0. And because that 9 is what we call a perfect square number, we can find two of the same number to multiply. However, one is positive and one is negative. So I'll start off each of my parentheses once again with an x. We'll have one parenthesis following it with a positive 3 and the other one with a negative 3. And that would be my answer. So then if we're looking at this last problem, notice x squared minus 16. That is going to be another problem just like what we did in problem number 5. Because I don't see that middle term of x, you can think of it as x squared plus 0x minus 16. And with a 1 in front of the x squared and no letter with that 16, there's no GCF. So we're just asking ourselves what is going to multiply to this last number of negative 16 but add to 0. So when we're thinking about our chart, to multiply to a negative means one positive and one negative. But remember, to make it add to 0, the numbers have to be the same. It's just opposite signs. So what multiplies to negative 16? Well, negative 4 and positive 4. Notice that if I was to add those numbers, there is my 0. So we have the two numbers that we're looking for. That adds to the middle term of 0. When I fill it in for my final answer, we'll start each parenthesis with an X. One of the parentheses ends with a negative 4. One ends with a positive 4. And that would be our final answer.